All right, I thought I'd make a video here explaining what was expected on this assessment, which was supposed to be actually a 40-minute assessment, but I forgot to adjust the times because it was meant to be short, especially as we did 2 problems exactly like this in workshop on Friday. So here we go, part 1. So dy dx is going to be 1 over 1 plus 2 minus x squared times the derivative of that, which is minus 1 over 1 plus 2 minus x squared. Now don't ever multiply stuff out. It's not needed in this course. So here's the derivative. Okay, and so the tangent line is minus 1 over 1 plus 2 minus 1 squared, and that's minus a half. Okay. All right. So that's minus a half. All right, so the point of tangency is 1 comma tan inverse of 2 minus 3, which is 1 comma tan inverse of minus 1. Now remember, tan of y lies between pi over 2 and minus pi over 2. So when you're computing this, when you're finding this thing here, you need the unit circle. You need the unit circle. Right, and what it's saying is the tan of y equals minus 1 over 1. So you go, okay, I can either be in quadrant 1 or quadrant 4. Well, it's negative in quadrant 4. So you do that. And so that's positive. That's negative. And this is the square root of 2. So this must be minus pi over 4 based on the unit circle. Okay. And so the point becomes 1 comma minus pi over 4. And then to write the line down, just do that. If you put some random picture like this, that's not right. No one writes a triangle like this. This is minus 1, this is 1, this is 2, root 2, out in space. The only time you would have a negative would be if you were actually on the unit circle here, which is what we're doing. We're working on the unit circle. And I made this pretty clear in class, but some of you heard it and some of you didn't. Okay, so that was problem 1. Problem 2 said let f of x be x times x plus 1 to the 2/3 on minus 9 to 7. And you were supposed to find all the extrema local and absolute. Okay, so you take the derivative and you get x plus 1 to the 2/3 plus x times 2/3 x plus 1 to the minus 1/3. All right, you're setting this equal to 0, and so what you want to do is find a common denominator, which is sitting on the right hand side there. So just multiply it by 3. All right, and so this becomes 3. So x plus 1 to the 2/3 plus x plus 1, this should be 1/3. 1/3 plus 2/3 is 3/3, so it's x plus 1 plus 2x over 3 times x plus 1 to the 1/3, and that's 5x plus 3 over 3 times x plus 1 to the 1/3. Okay, all you did was find a common denominator. That's all you ever do. So this gives us interior critical points. X equals minus 3/5 and minus 1. And we know the other ones, they're minus 9 and 7, so we have minus 9, minus 1, minus 3/5, 7. And then we're going to have f of minus 9 is minus 9 times 4. F of minus 1 is 0. We'll leave f of 3/5. F of 7 is 7 times 4, which is 28. Alright, and the minus 3/5 is sort of a hassle. So when you plug it in, you get minus 3/5 times minus 3/5 plus 1 to the 2/3, which is 2/5 to the 2/3, and this is what? 4/25 to the 1/3, and that was given. 4/25 to the 1/3 is a half. Approximately. Okay. So this is clearly the absolute max, absolute min, and to get 0, to figure out what this guy is and what this guy is, we really do have to make a graph of this thing. Right? So I get that x times x plus 1 to the 2/3. Okay, so we exploit the zeros here. We have a 0 at 0 and a 0 at minus 1. And so as this thing goes off to infinity, on the right, I get infinity. So this happens. That's 0. And then at minus 1, because it's squared, it has to do that. Anytime you have a multiplicity of 2, it goes off to heaven. So it looks like this is going to be a local max. And this little minus 3/5 minus 3/10 is a local min. Okay. After Thursday, we'll have a much better way of figuring out how to find out if they're local maxes and mins. And I just have to say this, because if you have f of x equals x times x plus 1 to the 2/3, And your next line is this. Something happened. You went online, you got help from another person. Maybe this was solved somewhere else in a book, and you happen to have the book, and you look that up. But this isn't what the course is about. This is about you getting from here to here, using the skills, not just writing down the derivative based on a derivative calculator that you can probably find online or anything like that. All right. Hopefully that helps.